Hi to everyone. Myself Dr.S.P.Saranya, Department of Commerce with Computer Application, working at Dr. S.N.S. Rajalakshmi College of Arts and Science. Today's topic is Python recursion. So in this session, we have to see about the introduction of the recursion in Python and what is recursion, why use recursion in Python. So recursion is the process of defining something in terms of itself. For example, a physical world would be to place two parallel mirrors facing each other. That is the real world example. I think it's easy to understand you. And then any object in between them would be reflected recursively. This is also the object example. So in the Python language, we know that a function can call other function generally. Up to last session, we seen that the function call its other function that for example local, non-local and the global sessions. It is even possible for the function to call itself, that is called recursive. So these type of construct the termed as recursive function. The following image shows the working of a recursive function as called recurse. As usual, the DEF is a keyword of Python function declaration and recurse as a function name. So within the recurse function, we have to call recursor. The call itself, a function it's called itself. It is called a recursion file function. And then in the Python, it's also possible for a function to call itself. A function that calls itself is said to be recursive, I already told. And the technique of employing the recursive function is called recursion. It may seem peculiar for a function to call itself, but many types of programming problems are the best expressed recursively. When you bump up against such a problem, recursion is an indispensable tool for you to have in your toolkit. By end of the final, what is it mean for a function called recursively? That means it comes from the Latin word recursion. It comes from the Latin word. Its meaning to run or hasten back. That means return or revert or recur. And then recursive definition is one in which the defined terms appears in the definition itself. Self-referential situations often crop up in real life, even if they are not immediately recognizable as such. If, for example, suppose you wanted to describe the set of people that make up your ancestors, you could describe them as this way. Your ancestor is equal to your parents plus your parents' ancestors. Notice how the concept of the being defined ancestor shows up its own definition. That is the recursive definition. Why we use the recursion? That means most of the programming problems are solvable without the recursion. However, some situations particularly lend themselves to a self-referential definition. For example, the definition of ancestor shown above. If you were devising an algorithm to handle such case programmatically, a recursive solution would likely be cleaner and more concise. Traversal of tree-like data structures is another good example because these are nested structures. They readily fit a recursive definition. A non-recursive algorithm to walk through a nested structure is likely to be somewhat clunky. This is the example of I have given here factorial representation. Definition of factorial, it's called nested itself. So it's calculated integer if double is equal to 1, return value is 1. So number equal to 3, print the factorial of num is factorial of num. the output what we get it, that means the factorial of 3 is 6. So thank you for watching this session.